Hello and welcome to the third video in our iNav flight series. Now, so far in the first video we talked about what iNav was, and in the previous video we talked about how to set up and configure your magnetometer and your GPS and connect it to your flight controller. Now in this video what we're going to do is we're going to install iNav onto the PC, we're going to connect up to the flight controller and flash it with iNav, and then we're going to go through the very basic configuration to get it ready for its first test flight. Now we're actually using this model here. This is the one that we added the GPS to in the last series. This is a Warrior 200. It's a little quadcopter and it's using a Seriously Pro F3 Mini or an SPF3 Mini flight controller. Now the reason that we've used that is because it doesn't have that 5883 onboard magnetometer, and using iNav we can decide that we want to use the magnetometer that we've connected up through the I2C pins up to the one that's part of the GPS. Now if any of that didn't make any sense, I'd recommend going back and watching the previous video where we go through all of that in quite some detail. The board we'll actually be setting up today is this one here. Now this is an omnibus board. It's quite cute. It has all of the stuff that you'd expect from an F3 based flight controller, but it does include an onboard on-screen display as well. Now the reason that we're going to set this up is later on in the series we're going to add iNav to a fixed wing, and this is going to be a great board to do it because it's going to allow us to also very easily pop the on-screen display into that model as well. So the first thing for us to talk about is how you actually install iNav onto your computer and then get it onto your flight controller. And it's exactly the same way that you do it for downloading Betaflight, CleanFlight or any one of the other family of products. The easiest thing to do is go and open your Chrome web browser, go to the Chrome Web Store and search for iNav, I-N-A-V, and you'll find iNav Configurator. Just click on the plus add to Chrome. Ours is showing us rate it because we've already installed it, and then you'll be able to run it just like you would any Chrome application. Once you're running it, it looks like this, and what we need to do now is go and install iNav onto your flight controller. Now most flight controllers will come with either CleanFlight or Betaflight pre-installed, not iNav. So the first thing we need to do is just double check what target or board type the board actually has on there so we know what firmware we need to flash. So the easiest way to do that is plug your new flight controller into your computer using the USB cable, wait for it to appear as one of the ports in the top right hand corner, click connect, and then you'll probably find you can only see the command line interface. If you try and click on any of the other tabs, it'll say that you can't do that because it's not running an iNav version. What you need to do then is type version in the interface, in the command line interface, and then it'll show you what you're running. And here you can see it's an omnibus board actually running Betaflight 3.0, which would have been fine if we weren't bothered about the GPS flight modes. Now there is a little wrinkle here. Occasionally when you get these kind of boards and they reboot into DFU mode, it doesn't appear on your computer. Now that happened on ours here, and the easiest way to sort that out is to use something that we've played with a lot already, something called Zadig. Now you can download Zadig, and what you do is you run Zadig, you list all devices, you find the STM32 device in DFU mode, you click on the replace driver, and then when you go through the process again, it'll find that and it'll appear as a DFU device, and you will be able to flash it. So now we have done that, let's plug the board back into the computer, and we're going to go through the basic configuration first of all. So we're going to click connect, and here we are looking at our newly flashed flight controller. Fantastic. Now the first thing you'll notice over here on the right hand side is we have lots of things passing and failing, but it will only arm once all these go green. Now of course the UAV isn't level, the board actually isn't level. If I hold it level that will go green, but the accelerometer isn't calibrated, and we have a few things we have to do. Now everything we're going to go through here is very similar to the stuff that you do for CleanFlight and Betaflight. So if you've already set it up, a lot of this is going to feel pretty standard stuff. So for this stuff I'm going to go through it at a pretty fair pace. So let's cover the stuff that isn't iNav specific. Go into ports. You need to configure a couple of things in here. UART2 is typically the one where we're going to have our GPS installed, and I would set it up like that. UART3 is normally where we're going to have our serial receiver installed, things like the Spectrum satellite, or also things like S-Bus. So let's set that up first. Click Save and Reboot. Let's turn Auto Connect on. That's going to speed things up. Next thing we need to do is go into the Configuration tab. Now, one of the nice things in iNav is until you've got everything set up, it won't enable motor and servo output. So that's to make sure that if you're installing this little guy in a plane, that you don't send the incorrect signals to the servos and start getting everything very unhappy. So we're going to have to select the frame type that we want. We're obviously going to be very happy with a Quad X. Motor layout is exactly the same as CleanFlight and Betaflight. So if you've already wired the board, or you're upgrading one of the other flight controllers you're already using with one of those to iNav, then you don't have to change any of the settings. Configure your ESCs for whatever you have, one shot 125 or whatever it is. Save and reboot again so you can save all that stuff so it's nice and sorted. Next thing we're going to do is we are going to jump into the receiver tab, exactly the same as we normally would. Set up the receiver in the usual way. Don't forget, this is the slightly older version of the graphical user interface if you're using the very latest version of CleanFlight. So all the receiver settings itself is actually in the configuration tab down here. So if it's going to be a serial based receiver and it's going to be S-Bus, this is where we're going to need to save that. Go into receiver itself, make sure that they're all moving, confirm that the midpoints are 1500, use your subtrim menus to get it exact if it isn't, make sure it doesn't go below 1000 and above 2000. That's all the stuff that's up here in the notes. Next thing to do then is set up your flight modes. None of them are configured by default. You can use arming switches or whatever you want. I typically make it so that angle is in the middle mode, horizon's usually in the middle, and then you also have our GPS modes. Now we will play with those later once we're happy that everything is working perfectly. So for now I would probably do something like nav alt hold and pop that up there like that and save it, because we do need to test altitude hold is working fine with the barometer. Once we've done that, then it's going into the motors, doing ESC calibration just like you would normally, and the final thing you need to, that you're probably very familiar with, is in configuration just make sure that any of the extras that you want are configured in terms of black box, LEDs, all that kind of wonderful stuff. Now that is all of the pieces that you'd expect to use as part of something like CleanFlight. So now we've spent a little bit of time looking at that other board, let's go and show you how we've configured and the steps we've gone through to get the flight controller in the model that we looked at here ready to fly with iNav. Now this of course is the one that we connected the GPS and the compass to, so I'll plug it in, we'll connect, and here is the model. Now, a couple of things here that you'll probably find. First of all, it's saying that the navigation isn't safe, and we'll talk about that in a second. But one of the things you have to do is make sure that all of the pre-arming checks are happy. If any of these are showing red, like navigation is safe, it's currently showing fail, and that I expect is because my GPS hasn't got a fix yet, then the board won't arm and you can't fly. It's a great visual indicator to let you know what you need to do and where the problem might be that's stopping you taking off. Now we'll go into configuration, and here I'll show you what I've got set up. Now the first thing I would recommend is go and make sure that all of the sensors are properly identified down here. Now when you install iNav onto the flight controller, it will auto find and configure the sensors that it can see, but if you have multiple sensors it might be picking the wrong one. Now when I first installed all the bits and pieces, I was having trouble getting the external compass to work because I'd switched the two cables the wrong way round, and you'll know everything's working fine if it's all nice and blue up here. If any of these are red, then you know you potentially have a problem. Now on the board that we're using, the SP3 Mini, then we would normally have a different magnetometer, but I've chosen the HMC 5883. That's the one that's external that we installed in the last video. So I'm using the external compass, the onboard magnetometer, and the onboard barometer. The other thing that I've configured as well Here's the GPS. I've turned on GPS, I've set it for U blocks disabled, and that's my magnetometer declination in degrees. Now there is instructions in the manual on how you find that out, so go and find out from your location what your magnetic declination is, and you just put it in that box. It's pretty straightforward. Once you've got that set up, hit save and reboot, and that's the first different part done. Once it's all set up, going back into the main screen, you should find then that everything is nice and blue, everything looks very happy, and you're also getting a nice 3D fix. And now my 3D fix is there. There we are, all my pre-arming checks are done. On a brand new board, you'll notice that a lot of these won't be set. Things like the accelerometer calibration that we had in the board that was brand new wasn't done. So let's talk about calibrating the accelerometer next. Now normally on CleanFlight the way it works is you just click calibrate accelerometer, you have the model flat on the bench and you are good to go. Now the challenge with this is that you actually have to put it in one of 6 positions, and we looked at that in the manual in the previous videos. And the trick with this is that you have to go and register each of those 6 positions, and when you come back it should be pretty level. Now I have mounted my board the right way up, so it isn't upside down or anything wacky like that. The calibration should be done for the board, not the aircraft. So if you have mounted your board upside down, the first position would be with the board facing up or the model upside down and vice versa. But the simple way to do this is, first of all, put your model completely flat, the board facing up, click calibrate accelerometer, then move your model into the position shown in the manual. So on that side next, click calibrate accelerometer, and then do each side in turn, calibrate accelerometer, until you have completed each of the positions. It doesn't have to be exactly 90 degrees, but the closer you can get it, the better it'll be. Once you've gone through all that and you put it down flat, then it should be reasonable in terms of its position. You then don't calibrate any drift with trims on the radio. You use the stick commands to trim it if you need to, but I found that this has got me very, very close to level. I'm actually sat on part of the desk that isn't completely level, and it's actually showing me why my pencils always drop off the side of that desk, because it is not completely flat. The next thing you have to do is calibrate the magnetometer. Now the magnetometer here is external. I've actually got the model on my desk near the mic and the speakers, so that's why we're getting a little bit of interference and a little bit of movement. So the way you need to calibrate the magnetometer is you click calibrate magnetometer, and what you need to do is exactly the same, is put the craft in each orientation, each side of it facing the ground. Try and do that a couple of times within the time that you have. You only get 30 seconds by default, which isn't a lot. And then once you've done all that and you put it back down, it should be facing north when you point the model north. And I would use something like Google Earth or a compass if you're not sure which way north is for you. If you find it isn't completely spot on, then there's a couple of things to do. I would probably try and recalibrate. I found here that I was having some weird problems, and when I tilted the nose up on the craft, you see as I'm tilting it, the heading isn't changing that much. One thing I found was that as I was doing that, as I tilted the craft, even though I wasn't tilting it, it was doing that all the time. And that's because the magnetometer position on the external GPS puck isn't exactly lined up. A lot of the magnetometers are actually mounted underneath the board with the GPS antenna and stuff at the top, and because of that you need to set that up. Now if that happens, go into configuration, go down here and board and sensor alignment, and sort out your mag alignment. Now I had to select each of these in turn until I got one that worked perfectly. The one for me with the M8N GPS unit that we're using here, CW 270 degree flip, was perfect, and that got me working. So once you've done that, we have our sensor set up, we've got our GPS running, we've done our calibration. I would move it around, make sure that everything looks level, and make sure that when it's pointing north, it's reading north, and also make sure that the GPS coordinates are, in fact, we're getting a fantastic number of satellites this morning. We usually only get about 10. We obviously have a lot of the constellation above us this morning. We're indoors, so even indoors I'm getting a fantastic reading. Shows how good these M8N GPSs are. Last couple of things to do is to configure Failsafe. Now we have an entire video on what Failsafe actually does, but it works a little bit different in iNav. Now the normal way it works in Failsafe, it protects you from two things. One is a disconnect between the radio and the receiver, and a receiver then will typically go into either no pulse, or it will output a predefined set of PWM values that you set on the radio, or it also protects you from the cable or the connection between the receiver and the flight controller on the model itself having a problem coming loose or being broken. Now iNav treats those two things as a fail-safe condition, and it will initiate it as the same. So in clean flight it treats it slightly differently. With iNav, what you either need to do is set up your receiver so it sends out no pulses in the event of a problem, or if you have a receiver that something like a Spectrum where it will always default to outputting some PWM value, and typically that's the one that it heard when you bound it and set up Failsafe, then the thing to do is go into modes and set up something called Failsafe mode. So when the radio disconnects and goes into Failsafe, it activates Failsafe mode, and that lets the flight controller know that you've got a problem. And that way, if the connection from the flight controller to the receiver, or the receiver has a brownout or something and the pulses disappear, iNav knows there's a problem. Similarly, if the radio and receiver connection has a problem and the receiver goes into Failsafe and that Failsafe is set up to trigger the Failsafe mode, then iNav will do exactly the same thing. And what iNav does in the event of a Failsafe is one of two things. If it has a valid GPS fix, then it will initiate a return to home and try and fly back to you. If, however, there is no valid GPS fix when the failsafe happens, then it will initiate a controlled landing. And that will happen irrespective of whether or not it's kind of a no pulse situation or whether or not you've actually activated that failsafe flight mode. Last thing to do then is to actually configure the GPS flight modes. Let me quickly show you those. Here on the board I've got it set it up so we're always flying an angle for the test. I don't want to try anything else. In the middle position I have kind of a 3D GPS hold going on, so we have nav position hold, we'll hold it in 2D space, and I've also turned on nav altitude hold as well. Now we'll talk in the next video about the process to go through to test all this stuff in a nice controlled way to minimize the chance of you having a little bit of a hiccup. But the nav altitude hold has a default throttle value for hover, and you might have to tweak that a little bit to get it working great. We did here, but don't worry about that, we'll cover it all in the next video. The last thing then, of course, is make sure that you have enabled your outputs. You might have to do this in order to calibrate your motors, but once you've got all that set up, then I would just confirm that you can arm the board, you can run the motors on the bench, and then you can fit the props, and then we're ready for the next video where we're actually going to go through the process of making sure things like the altitude hold is working, doing the checks for the GPS hold, and finally making sure that the GPS return to home and failsafe are all working too. So join me in that next video where we'll start testing things out. Thank you for taking the time to watch that video. There are lots of other videos on the channel and they're carefully ordered into playlists, so you may find that there are other videos on this same subject that you can go and watch. So I would recommend going into the playlist area of Painless 360 YouTube channel and looking around and seeing what there is. You never know what you might find. Thanks for watching, please like, subscribe, and happy flying.